Congratulations, we're at the home stretch, the last lesson of this chapter. In this final chapter, we're going to spin up a load test instance, install some load testing software named Siege on this instance. We're going to then use Siege to load test our Drupal application and verify that we see our application scale up and down. Before we continue, make sure that you've done the review stack in WebGUI. You should have completed all other exercises in this chapter. It's also highly suggested that you've gone through the rest of the course. We only need about 30 more minutes more time from this point forward. Again, this exercise has already created multiple instances in AWS, and you will be charged unless you terminate your stack when you're done. We'll show you how to do that in this chapter, but make sure you've done it when you're done with this course. You don't want those resources laying around on Amazon charging you money. Back in a web browser, you should have the following tabs open: CloudFormation, EC2 with the view on load balancers, EC2 with a view on your instances, and Drupal selected as the filter, a tab for CloudWatch, a tab for RDS, a tab for your ELB's endpoint, a tab for the instance on AZA, and a tab for the instance on AZB. The first thing we're going to do here is create a new instance so we can install some load test software on it. What we need to do next is create our machine to install Siege on it. Let's go ahead and push Launch Instance from our EC2 tab, third one from the left. Use Classic Wizard, Amazon Linux AMI, 1 T1 Micro. We don't care about AZ. All these defaults are good, as well as these. And let's give it a name of Siege Test Machine and push Continue. We'll use our existing production key pair, and we can use our My First security group. You could also create a new security group that has just SSH access from outside. Everything looks good here. Let's go ahead and launch it. And let's view our instances on the Instances page. Here we see our Siege test machine spinning up. Let's go ahead and refresh this a couple times until we see the DNS that's provided for it. Once you have a DNS entry point, let's go ahead and copy that out. And then flip over to a terminal and get ready to SSH in the machine. We're going to SSH-I, path to your production key, EC2-user, @ and then the DNS. Don't push enter just quite yet. Instead, in the text editor of your choice, please open 1805 Installing and Using Siege. These are the step-by-step instructions that we're going to need to install our load test software, configure it, and then run it. Let's hop back to our EC2 page and see how that instance is coming up. Refresh a couple times until you see 2 out of 2 checks passed, meaning that this server is ready to accept SSH. Let's go back to our terminal and SSH into this machine. Accept the new key, and boom, you should be in. From this point forward, all we're going to do is copy and paste commands from 1805 Installing and Using Siege into our Siege test machine. So let's start at the top. First, let's become the root user to ease the install and use of this package. Simple enough. Let's go ahead and CD into user local source, which is usually a good location to install external packages. Siege has a couple dependencies. Let's go ahead and install these packages now. After a couple seconds, we should see this screen. Let's go ahead and get the Siege package. Jodog.org is the company that provides Siege. Although the URL looks a little sketchy, they're okay. I've checked them out. Let's go ahead and get the package. Let's untar the package. Let's CD into our Siege directory. And be careful here. The version of Siege that you may have pulled down might be something like 301. If you get an error on this next command, look at the version of Siege you pulled down and CD into the proper directory. Let's go ahead and configure the package. Build the package with make, and then go ahead and type make install with 2 L's to install the package. And after a couple seconds, we should be here. Great. So we've done those last 2 steps, and now all that's left is running Siege. For this, we'll need the ELB entry point of our application. Let's hop back to our second from the left tab, which has the ELB properties. Let's flip over to the description tab and grab the DNS name. Copy your DNS name into your copy and paste buffer, flip back to your terminal window where you're logged into your Siege server, And next, we're going to hit the server with Siege. Before we do that though, let's check back on our CloudWatch alarms. Our fourth tab from the left is our CloudWatch alarms. Let's just refresh those. Here again we see that we don't have any alarms going off. Let's click on our Instances tab and filter again by Drupal. And here we can see that we only have the initial 2 instances still serving traffic. Let's flip to our Load Balancer tab and click on Instances, and this validates that as well. Okie doke, let's go ahead and run Siege. Back in our terminal window for our Siege server, we're going to type Siege -C to specify the number of concurrent connections, and let's use 20, -T to specify the length of time, and let's give it 7 with a capital M meaning minutes, and then type http:// and paste in the ELB entry point. This is going to run 20 concurrent connections for 7 minutes against this URL. Let's go ahead and push enter. And we can see the various results start coming back. The ones in light blue are one server, the ones in dark blue are another server. So we can see our load balancer balancing back and forth between the two of them. Again, this is where it comes in handy having one server in a quote-unquote error state. If we flip back to our web console, let's start monitoring the CloudWatch alarms. Within about 2 minutes, you should see one of these alarms go off. You can keep refreshing until that happens. While we're waiting for our alarm to go off, let's shrink down our console a little bit so I can show you the terminal running. Here we can see that Siege is reporting anywhere from about 0.2 to 1 or upwards of 2 or 3 seconds lag. This is definitely going to fire this latency greater than 200 milliseconds alarm. We just have to keep refreshing and waiting for it to happen. Actually, while we're waiting for it to happen, let's review our history of our alarm as well. We can see in my case, at one point it did move from insufficient data to OK. This is because I hit my ELB endpoint or I hit my individual servers, at least giving it enough data to register. Right now we're in no data, nothing was hitting it, until we started Siege off. Let's actually go ahead and click on Dashboard so we can watch our alarms at a high level. Excellent. Eventually my alarm went off. Let's go ahead and click on it. And it's exactly what we expected. Latency greater than 200 milliseconds for 2 minutes. If we look at our history now, we can see that an alarm happened, and we also executed an auto-scaling policy. That's great news. That should mean that we're spinning up servers. Let's flip back to our EC2 Instances tab, third from the left, and refresh. Exactly what we expected to see. I waited a little long, so my servers are already up, but I can see that I now have 2 additional servers added. Remember that auto-scaling policy only adds servers 2 at a time, so that even though my server is under heavy load from Siege, it's only able to add 2 at a time. After another 2 minutes or so, I'll get another alarm firing, and I will see more instances added. While we're waiting for 2 more instances to load up, let's flip over to our ELB page, and let's refresh on this page. Here I can see that 2 more instances were added, and distributed evenly across my AZs. These other 2 instances that just got added aren't up yet because they haven't passed their health check. That will happen eventually. If we flip back to the Instances page, let's just keep refreshing this page until we see 2 more instances added. And eventually you should see what I'm seeing. Now because we set a max of 6 instances on our auto-scaling group, we'll never get beyond this, even under heavy load. If Siege hasn't completed yet, go ahead and kill it. Let's relieve some load off of our server. Let's also go back to our CloudWatch alarms and click on Dashboard. Here we can see that 2 alarm thresholds have not been met, so they're in OK state. Our 1 for scaling up has been going off like crazy. Let's go ahead and click on this alarm. Now one thing to be aware of is I know that this alarm had to go off more than once. The web GUI is always going to lag behind a little bit. If we ran API commands, we would see this alarm going off more than once. Here we're only seeing it once because the CloudWatch GUI is a bit delayed. While we're waiting for our scale down events to happen, let's review our ELB metrics. Under Metrics on the left rail, let's go ahead and click on ELB. Let's open our detailed view up a little bit and click on Latency. We've only been running for a little bit, so let's go ahead and expand this view out. And we can see that our latency went from really nothing all the way up to very high values, above 2 seconds. Eventually, this should come back down because we've relieved all the load off of the machine. While we're waiting for our scale down events to happen, let's flip over to our ELB page, and let's see if those health checks are coming through for other instances. And eventually you should see that all are in service. This is really cool, noticing that we've got half distribution evenly across our availability zones. As long as you make your scale up and scale down events happen in factors of the number of availability zones you have, you'll always get this nice even distribution. Even though Siege is closed down, we're going to eventually run with insufficient data on our other alarms. Let's at least hit our site a couple times just from the ELB endpoint on a regular browser. Again, just do this maybe once or twice. And that will give the other alarm, the latency under 0.1 for 2 minutes, a chance to kick off. You can see here that we're viewing all alarms, and sure enough, our alarm for low latency is kicking off. And we can see here that this successfully executed the policy to scale down. Let's flip back to our EC instances view and refresh a couple times. And sure enough, we see servers shutting down in pairs of 2. If we let it run on long enough, we'll eventually scale down to the minimum that we set for that auto-scaling group, which is 2 servers. Let's also look at something interesting inside of CloudWatch. I want to show you how much this entire course has cost me inside of Amazon. If we go under Metrics and select Billing, and we select Amazon EC2, we can see that just today I've only spent about 50 cents. I've spun this stack up maybe 2 or 3 times. That is really, really cheap to be able to do what we're doing. If you want to play with your stack a little bit more, feel free to do so. But I'm going to, at this point, shut down all of my instances and all of my servers, just to make sure that I don't get that $260 bill at the end of the month. Again, if you want to play with things, go ahead and do it. But please be aware that the meter's running and you're being charged per hour. The first thing we're going to delete is our entire stack. This is one fantastic thing about CloudFormation. We can create a stack with a single button push, and we can delete that stack with a single button push. Let's go ahead and select our stack, and again, this is only when you're finished with it, and push Delete Stack. Confirm the dialog, and we go to Delete in Progress. The deletion will take about 20 to 30 minutes as well, so be patient for that. If you are at the end of the course, please make sure that you clean up all of your resources. I myself know that I had a couple other instances running. I'm going to flip back to my Instances tab, take off the filter, and then kill all the other machines that I don't need. For example, the Siege test machine. If you refresh a couple times, you see that sure enough, your Drupal instances will start dying as well, because the CloudFormation stack is shutting down. This would be a good point to review S3, IAM, and other areas of this account where you may have resources laying around. If you decided not to delete your stack, or if you want to just create it later, there's a lot of cool stuff you can do with this stack. You can test the RDS failover. This is a great URL to do that. You can also terminate instances in your autoscaling group and see if they reappear. This should especially happen if you're down to 2 instances and you kill one of them. You could also kill all instances in a single AZ and see if your application still serves traffic. Another great thing to do would be installing the command line autoscaling tools and resizing your autoscaling group up and down. This is the URL to accomplish that. Whatever you do, please make sure that you don't forget to delete your CloudFormation template. If you leave this full stack up, it's going to cost you at least $200 to $300 a month. I'd hate to see you getting stuck with that bill. When you're done, make sure you do a delete stack from the CloudFormation web GUI, right there. Huge congratulations! You should now know a ton about AWS. Try to use this knowledge and keep it fresh. A great way to do that is use CloudFormation templates to quickly spin up and try different services for proof of concepts. And use this knowledge at work as much as you can. Amazon is changing all the time, and it's really important to stay on top of developments. Especially try to avoid recreating wheels. These are some of the best ways I know to stay on top of things. Local AWS meetups, which you can find on meetup.com, reInvent conferences, and AWS formal training, which you can get from Amazon and other providers such as Global Knowledge. I've really enjoyed teaching you this course, and I hope you've learned a lot of valuable stuff about AWS.